Hi everyone, now we're going to have a look at counting arrangements. Okay, so we talked a little bit today about ordered and unordered selections. So this is where we really need to be quite careful. So if we're looking at counting arrangements, we're looking at ordered selections. So where the order that we choose the people in is important. So let's say, for example, I've got 6 people in a line. I've got Michaela, Callum, Daniel, Joshua, Shana and Riverina. How many ways can they be arranged? So I've got my boxes for 6 positions. There are 6 people that I can choose from for the first one. But once I've chosen that person who's first in the line, I only have 5 left to choose for the second position. Once I've chosen that second person, I then only have 4 people left to choose from for the third position, and etc. Until the last position, I only have 1 person left who inadvertently just fills that last position. So 6 times 5 times 4 times 3 times 2 times 1 gives me 720 possible arrangements. And I'm just using this multiplication principle that we talked about today in class. If I go all the way down, if I've got 6 positions and 6 people to choose from, then obviously I'm going to continue multiplying until I get to 1. If I do this, this is called factorial notation, and it's represented by the button on your calculator that has the exclamation mark on it. So that's this one here. So x to the exclamation. So if I'm entering 6 factorial, it's 6, and I'm using, I don't need to press shift, sorry, and I get the exclamation mark, and that will give me 720. However, the factorial is only when I continue to go down by 1 each time until I end up multiplying by 1 at the end. So n factorial can be written as n times n minus 1, 1 less, times n minus 2, another less again, continuing to go down until I get times 2 times 1 all the way to the end. However, when I look at counting arrangements or ordered selections, they're not always factorial because they don't always have 6 people and 6 positions. So for example, if I had these same 6 people, but I wanted to choose 4 people for a photo for the local paper. So I've got 4 people that I want to choose. So I have 4 positions or 4 boxes. 6 people I can choose for the first one, 5, 4 and 3. Now the fact that they're not in a line doesn't make any difference, but the fact is I've chosen only 4 people from a choice of 6. So I'm not continuing to go down times 2 times 1 because I don't have 2 more positions. So I'm not going to be able to use my factorial notation. I simply just have to multiply this along my calculator, 6 times 5 times 4 times 3, which gives me 360. The next example I might have is if I've chosen a captain and a vice captain from these 6 people. So the captain, I have 6 people to choose from. That's important in the order because the next person that I choose is not the captain. The next person is going to be the vice captain. And there are only 5 people to choose from once I've chosen that first person. Remember, it's not like we talked about the green pencil going back in the pencil case. Things are going to change in terms of the probability because I now have 1 person who's taken out of that list. So I had 6, 1 now becomes the captain, I've now only got 5 to choose from. So that leaves me with 30. And again, I just multiplied out, I'm not using factorial. So we're looking at ordered selections where the order that you choose them in does matter. So remember, the boxes for the number of positions and the numbers in here are the number of possibilities or number of selections. How many are possible? What's possible for those? You can now work on exercise 604, questions 4 to 14.